All right, welcome in everyone. John here, staff software engineer, 10 years of experience, actually over that. I'm the lead maintainer of Latterly.io, an open source educational and networking platform that'll help you learn to code and land your first or next programming role and grow your professional networks. Also soft skills for non-programming career development. You could be a cashier or a waitress, something like that, and still gain from this program. You can sign up for free and join the Discord under the community tab. Hundreds of people on the Discord, come say hi. And today we are working on NeetCode. We're continuing to grind through NeetCode. We're going to work on diameter of a binary tree. This will be my second time visiting this problem. I visited it previously and did not get a working solution. So I time boxed it, reviewed the solution. And so now we will be doing largely a recall test. So I think I have the intuition, but let's actually read the problem first. Here we are, number 543. Given the root of a binary tree, return the length of the diameter of the tree. The diameter defined as the length of the longest path between any two nodes in the tree. It may or may not pass through the root. And the length of a path is represented in the number of edges. So this says 1, 2, 3, 4, 5. We don't care about any of those numbers. They're basically just node IDs. We can use them in that way if we want, but the values of those nodes are not very important to us. We want to count the paths. So in this case, I could count from 4 to 2 to 1 to 3, and that would be a length 3 because there are 3 paths. Or from 5 to 2 to 1 to 3. Okay, so how should we go about this problem? The intuition here, we can consider a simple case first. Consider the case when there's only one node. How many paths are there? 0. So we can say if not root or not root.left and root.right, then we'll return 0. That's just a guard. That's not really like solving the problem. And we want to do this should actually be an or, if there's neither of them. Okay, so if we don't have a root, or if we have a root and it has no children, there's 0 paths. But the simple case extended slightly further. What if the case when I have 1 child? Well, then there's a maximum of 1 path. That would be length 1. What if I have a left and a right child? Well, now I can traverse twice and I can get a value of 2. All of these are simple cases when I end up going through the root. In a more complex case, and by the way, in these simple cases, we take the far left and the far right and just calculate the distance from the far left to the far right. And this works for any of the simple cases that go through the root. In a complex case, there could be a nested tree that is wider than the whole tree. So let's visualize that. So here's a complex case. The root's way up at the top, but it only has 1 left child and 1 right child, but the right child has this wide subtree. So that the distance between this node down here and this node over here, this distance is wider if I go through this node and I never go through this upper node. So I'll go like this. That's a complex case where I want to go through a wide nested subtree. And we know that because either of these distances is longer than the potential distance I could get over here. So how do I identify this harder complex case? Well, if I take a DFS solution, which is natural even in the simple case, I can easily extend it to capture this case using a global or non-local parameter, one that's external to the scope of the DFS. So for the simple case, we want to use a DFS, and then we can extend that slightly with a non-local variable to accommodate the edge case where a nested tree is widest. And the cool thing about that DFS is, by the time I return up to the node, I'll have this other variable, and I will basically do like an OR operation or a maximum operation between 2 values at the end. So that's the intuition. And let's see if we can get this going. So I will return, I'll call this diameter, and I'll put it in all caps because it's going to be out of scope. Really, that's not, let's lowercase it. All caps would probably indicate a constant, and it's not a constant. So we'll return the diameter. The key thing here is that we are not returning the result of the DFS. We're going to do some calculation first. So diameter is max of whatever it was. We'll do the max. You could use a like an if-else and then check if it's greater than. You could do that, but I think this will be a more concise syntax. And we could just call this result maybe. So let's do a more descriptive variable name. And I'll call this self.dfs, and we will call that on root. In fact, we can use the diameter function itself as the DFS. You can see it already takes root. So we'll take the result of this, and that could be called I want to do this for the left and the right. Dot left and dot right. So this could be called longest left branch. That's a slightly more descriptive result. Now that we have two of these, we definitely don't want to call them both result. We can say longest right branch. So the diameter is either including the top node, which will be the longest left plus the longest right plus 1, the root itself. Actually, it's dawning on me that we might not need to do that extra 1. I'll put a to do. I don't think you add 1 in the root case because we're counting the branches, not the nodes, right? So I don't think you need to add 1, but I'll have that to do anyway. So longest left, longest right. And that's basically the high-level structure other than the logic of the DFS itself, where I'm collecting the, in this case, the length of the branch. Okay? So for any node, the longest left branch will be the longest left branch of the child plus 1. I think it goes over here. Because this will be from the child, and then here. Yeah. That looks more correct. Now, if this is the whole DFS, what if I dive all the way down to 4? So let's say I'm at the 4. So 4 will return 0. And it will come up to the 2. And the 2 will choose 0 plus 1. That looks right. It has 2 options, but it's going to be 1 in either case. And if the 5 was extended, it would be maybe a 3. So we seem to pick one of these. Right, so I want to pick one of these. Okay, so I think I do want to break out this helper. Yeah. There's a different condition at the top node. At the top node, I'm returning diameter, but for the children, I'm just returning the longest branch. So I'll call this longest branch. Longest child branch, I guess. It'll also take self and root. And in this case, I want to return the max of these two. Cool, and then by the time I get to that root node, I guess I will still add one more. Okay? So now this should solve for this happy case, but I'm not handling the diameter. Let's go ahead and test that. Cannot access diameter where it's associated with a value, where it is not associated with a value. Okay. In Python, I think I need to declare non-local. No binding found. Did I misspell it? Diameter. Okay, let's see. I could make an init method. And I'll put this on the class itself as opposed to a true global. That's nice anyway. Python practices, we like to scope these things. So instead of non-local, I'll add self dot everywhere. And it takes 0 positional arguments but 1 was given. Oh, this is something like the leak code. Serge, thanks for the rose. Arbitrary guy, thanks for the follow. And 30 likes so far. Thank you so much. Consider tapping the screen. Give it some more likes so the algorithm will send it around. So something is being sent into this constructor that oh, do I need self? Yeah. Okay. So we got a wrong answer. Why? Why did we get a wrong answer? From 4, 4 goes up to 2. At the 2 node, I have a path of 1. At the 1 node, I have 2 on the left and 1 on the right. 2 on the left, 1 on the right. I'm expecting also to get 3 by manual verification. Well, it looks like I have the logical algorithm right, but my code is wrong. Okay. So I've gotten 2, so somehow I'm getting 2 from left and right. This is the issue. 2 from left and right. Oh yes, I don't have the guard. So I need this guard also in the child method. This way the right hand will return 0 as opposed to 0 plus 1, which it was doing. So I'm still getting four somehow. Interesting. Because I'm calling the wrong method. Okay. All right, so I got this happy case done. So we just need to deal with the diameter now. I think we don't want to do that. Bro, the logic of the question makes 0 sense. So you just want to get the, oh, well, this diagram has gotten messy. Let me undo. Did you join recently? You just want to get the width of here, because that's the widest part of the tree. Imagine that you're trying to pass this whole tree and all its nodes through a tube. What's the diameter of that tube? That's what you're solving. Does that make sense? Thanks for the follow, Yonatan. Thank you. All right, so I'm doing everything except the diameter. So how do I calculate this diameter? The diameter will be at every step calculated. And it's always going to be the max of whatever it already was, and then possibly this current subtree. So I'll call this cur width, and that's going to equal longest branch plus longest right branch. Okay, so this is still wrong. And why is it wrong in this case? It's wrong in this case in the 2-node case because I am adding the 1 whether or not the child exists. Good, 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 good. So these should default to 0, and I should only increment them if the child actually exists. Okay, so the longest left branch, and you could also do an if-else syntax if you want to. I'll refactor that if this works. And I will say if root.left, then. You see that bonus 1 was kicking in regardless, which is why I was getting 1 too many. So the longest left branch is the child and 1, if and only if, IFF, if and only if that child actually exists. Viral Clips, thanks for the follow. Davey, thank you for the follow. Okay, and if the right child exists, then the longest right branch will be the child plus 1. How about this? So I've still gotten a wrong answer here. Why do I have a wrong answer here? Because I need similar guards up here. I need to guard the root in a similar way. The base function and this helper function look so structurally similar. I think that I could consolidate them, but that's like something we can do later once we have a working solution. So we'll default this to 0 and increment if and only if the right exists. Good. Wrong. So we got most of the, oh, null. So there's some nested nulls here. I'm not sure. I'm not sure. Something with this diameter calculation, I guess, is wrong. The diameter is the maximum of whatever it already is and the current width. How am I calculating this current width? The current width is the longest left child and the longest right child. Yeah, that seems correct. Does it treat nuns as a subtree? We shouldn't, right? If there's a none, we return 0. So what if we return, yeah, if root.right. Could be something to do with that, chat. Good call. So what if the node exists, but it has no children? We should still count the path. It'll still create a path. And it's an off by 1 issue. What if you return nothing instead of 0? No, we want to return 0 because we want to accumulate the length of that longest branch. So we don't want to just return a none. Ah, okay. We do want to tell the difference between... Maybe I need to break this guard into 2 steps, eh? So if you don't have any children, then we're returning 0. But if you yourself don't exist, maybe we want to return a none in this case. What would that do? Well, it should never have come here because of these guards. What about in this case? If root.left, if root.right, then we're guaranteed that the node exists at least. So I don't think that that helps us. Interesting thought, but I don't think it helps us. Ah, but my condition is wrong. I want to say if not left and right. I want them both to be nullish. Then I return 0. If not left and right. And that's wrong in this case. Why? Okay, I think something is wrong with my condition here. Let me spell this out. If not root or not left root and not right root. Okay, so what if I do this similarly? Somehow my join here was not the right logic. If there's not a left child and there's not a right child, then we return 0. Nope, still wrong. Okay, I'm not capturing this correctly. I'm going to go ahead and look up the solution. Let's look at the difference here. We can also take it over to ChatGPT at this point. This is slightly different. So where they're adding the 1. Diameter width is the one best I can't do. BFS. Yeah, really rough to do this problem BFS, to be honest with you. Highly recommend DFS here. So it makes sense that I'm getting an off by 1 problem, given that they add the 1 differently. They add the 1 differently. Okay, so let me try that. Yeah, so the longest left branch, and I think my naming has confused myself here. This should be like the longest left child branch. Oh, and look, I'm using the wrong method here as well. All sorts of mistakes. Okay. That didn't make the difference. So whether I add it here or if I add it here is equivalent as long as I don't do both. I could do either. But definitely need to make sure that we're calling the right method. All right, well, we got it. And I shouldn't have had to look up the solution with that, honestly. So that would have been an embarrassing interview performance, but we made it. Hey, thanks for being here, chat. If you found this interesting, I hope you'll follow the page, and I'll see you next time.